Good morning, everybody, and we are very delighted that Professor Arpit Agarwal, who is in the Faculty of Computer Science and Engineering Department, and also an associated faculty with C Minds, is delivering two guest lectures today and on Thursday. Professor Arpit's specialization is in human-centric AI, investigating the interface between human and intelligent machines. Professor Arpit did his PhD from University of Pennsylvania. After that, he did postdoctoral research in Columbia University and also in FAIR, Facebook AI Research, now called Meta. So please do listen to him with all your ears and attention. These are recent developments in AI. Over to you, Arpit. Thank you very much.
Okay. Good morning, everyone. It's quite early for you guys, I guess. But thanks for your attention. So today I'll be talking about this new paradigm called human-centered AI. And we'll be taking it easy. We'll just be thinking about some of the issues that are being currently faced and what are some of the important problem directions that are being faced in AI. So this course is more foundational in nature, but this research area is slightly showing you what are some of the important directions ahead, particularly when it comes to AI's use in society and its impact on humans, right? So this is basically a customary slide. All of you might have seen something like this, right? And use tools like ChatGPT. How many of you have used ChatGPT for these purposes? Any show of hands? Rest everyone has not used ChatGPT at all. Okay. Very surprising. I guess you guys are far behind the curve. You have significant advances in generative AI and other forms of AI. And you have these tools called ChatGPT and Midjourney. You can look at the type of images or the type of videos that they are generating based on a single prompt, right? And people are saying that it's the dawn of artificial general intelligence, because now you have AI that's able to learn and take action and interpolate and generalize from the limited set of examples that we have seen, right? But there are several problems that are emerging, and this is something which has been in popular news. So rise of social media, and particularly in the age of AI, we have AI generated content, which can be very, very addictive. And how many of you have seen this TV series called Adolescence? Okay. What? You don't have Netflix? Okay. Subscription. Okay. But you might have heard about it, even though you have not watched. I myself have not watched it. But it's becoming very popular, and it's about some aspect of it is about social media addiction, right? So you are the youth today. You can perhaps relate to this, but social media has become very, very addictive, particularly with the rise of AI generated content, right? This is perhaps you can relate to less. Maybe people who are interested in politics might be able to relate it to it. But the rise of social media and AI platforms have also led to rise in perhaps, or is linked to rise in polarization. So when you have algorithmic content being filtered based on your preferences, and preferences accumulating over time, you might have a phenomena where people of one view might only see content from one view, and people from another view only see content from another view, and maybe leading to polarization, like no sharing of views amongst two different groups, right? Uh, we have also seen huge amount of bias in let's say algorithms that make decisions for people. So it was found that in the US, you have algorithms for predictive policing or algorithms that are being used for granting bail to people. So people who have committed some crime, and you want to decide whether or not to give bail to these people. Judges are increasingly using AI algorithms for getting a score of whether the person will commit a crime in the future or not, right? And if it is likely that the person will commit a crime in the future, then you might not want to release them or give them bail. But if the person is unlikely to commit a crime in the future, maybe the original crime was just one of a like happened once in a blue moon, but it won't happen again, then maybe you'll give bail to the person. Okay. But what if the data that the algorithm is trained upon is biased, and you are giving more bails to one racial group, and in the context of US, this happens to be black versus white. So there have been studies which have shown that these algorithms are biased against the black community. So blacks are perhaps much less likely to get bails as compared to the white community, just because of the bias or the type of data that the algorithm is trained on. Okay. So there is also a lot of history of this type of bias being present in technology. Okay. So this is a classical example of photography. Okay. And it's important to think about this example because machine learning is a new technology. And what if we don't train it the right way, right? It can have certain amount of biases. Cameras are a very good illustration of this fact. So back in the 1970s, cameras only worked well on lighter skin. Okay, so they were mostly, mostly developed to capture lighter skins because a lot of this technology was developed in the US and elsewhere, and it didn't work well for it didn't work well for dark skins, right? And the irony is that it didn't take people with darker skin to change the technology. What happened was that chocolate companies and furniture companies were not able to capture their products very well because chocolate happens to be darker in color. They were not able to get very good advertisements for their chocolate because it was not able to capture the features of chocolate. And it took complaints from these companies to actually improve the technology to capture different spectrums, darker skin, lighter skin, and various in between. And similar type of things also happen in AI, for example. So if you have heard of image recognition technology or facial recognition technology, it often works very well for lighter skin, for example, doesn't work very well for darker skin. Okay? So this example shows us that whenever we are developing a technology, um, it will it is likely to have the human bias from the creators of the technology, right? If the creators of the technology are certain kind, then there is a chance that there is a bias seeped into the technology just by the virtue of the way of thinking of the designers of the thing, right? So this is a very nice example that illustrates this. And one thing is that since a lot of these AI models are being trained in the West, we have to think more carefully about this. Okay. How many of you have seen this example? You guys have seen this example. Okay. So what is this example showing? Can anyone say more loudly? Okay. So this is a very, very famous example. In fact, you can try this on your own actually. So you take something gender neutral, and the AI will basically fill in something which is gendered, but the gendered will be specifically according to the statistical bias it has seen in the data, right? So if doctors are more associated with he and nurses are more associated with she, you are you're more likely to see that being generated, and specifically in LLMs and so on, right? Now the question is this okay? Is this good? Is this bad? Right? It depends on your perspective. People might say that people might say that this is just representing the statistical patterns observed in the data, right? Now that's fine. It's there are statistical associations in the data that are present. But what if we develop this technology now, and a lot of the things that it sees are based on the data of the 20th century, let's say. But now society evolves in a certain way, and these stereotypes are not present in the society. We don't want our models to be lagged behind, right? We don't want our models to be trained on 20th century data and contain these stereotypes which are kind of outdated. And this can have problems, right? Because you don't want these things to be reinforced. The society has evolved in a certain way. You don't want these stereotypes to be reinforced just because your models were had these stereotypes. And you might not think that this is such a big issue, but oftentimes it happens that when technology evolves, there are a lot of rudimentary aspects that are actually encoded in the technology, but it doesn't get washed off very easily. Okay. So this I tried myself. So this is Meta AI tool, and I asked imagine president. Okay. So all the images of president that it gives is US presidents, right? And of course, you can see the flag is also visible in all of them, right? I never said imagine US president, but it automatically gave me all the images of US presidents, right? It could be president of France, it could be president of India, whatever, right? So no geographical diversity. Does that make sense? Now, any comments? Okay. So now Google tried to fix this. Okay, so this example on the right is this woke AI. So Google tried to fix these type of examples by including some diverse image generation. Okay. So they tried to specifically diversify the generated images, but it lead to another type of backlash, because then it became completely historically irrelevant. For example, when it was asked, show me images of US founding fathers, it showed images of like indigenous people, which were never founding fathers, right? When it was asked, like, generate images of German soldier in the World War II, it showed images like this, which are not at all representative of a German soldier, right? So how do you actually strike a balance, right? If you can you are if you are just completely unaware, you are just representing the data that you are trained on, in which case you will show all US president images. And in another case, if you include some diversity metric, you might get backlash that you are just being overly woke, or you are just being completely unrepresentative of the data that's there, right? So it's a difficult problem, and people have tried to strike a balance, and there are several techniques that you can use. But this example illustrates that it's basically a difficult problem. Okay. And the last example is from Amazon. It's basically when Amazon introduced this same one-day delivery, it was analyzed that so it introduced this one-day delivery or this prime delivery in certain neighborhoods, and it didn't launch that service in another neighborhoods, right? And this one-day delivery is actually very useful. You can get your whatever thing delivered in the same day, so it's good. It's nice to have, but it was launched only in certain zip codes or in the US. And people analyzed that a lot of the zip codes that the service was launched were actually white neighborhoods. So there was not representation. Okay. So we have seen many examples of the type of bias that can be introduced in technology or the problematic nature in which the technology could emerge. And so we have seen in this example some racial bias, lack of diversity, gender-based bias. We have also seen polarization and recommendation algorithms. We've also seen some issues with addiction and sort of uh, exposing youth to these AI generated content, right? So these are some examples that we should keep in mind before we think about AI. And how the question is, how should we design AI in a way that these examples don't repeat or these examples don't perpetuate, right? It becomes very important because now we are in the age of agentic AI or even physical AI, where AI has the autonomy to write code for itself. So you can have scenarios where the future AI is being developed by current AI, right? And if current AI has these type of biases, you can imagine after several iterations of this, what can happen, right? So it's very important to study AI in a way that it's human centered, that it works best for the best according to the human needs and augments human capabilities. Okay. So the idea is that AI should lead to productivity for humans and it should augment their capabilities. But at the same time, it should align with the societal norms and societal values. Okay. And it should operate ethically and transparently. You can add many more such sort of ideas behind human-centered AI, but I've tried to list down some of the important ones. So work according to human needs and preferences, societal values and norms, and operates ethically and transparently. Right? These are the important tenets of human-centered AI. Does that make sense? So who all are in for human-centered AI? Or who all think that human-centered AI is just, no, I don't care about all these things. Does anyone have that view? What happened? Didn't have breakfast or what? Okay. We need more interaction in the class. I think it's not ideal if you guys don't speak. These are current topics, and you guys should be excited about it, right? These are important things to think about and have debate on and so on, right? And with the US election and so on, there's a lot of debate around these things, and this stuff is really important. For example, Professor Pushpak, uh, he's leading the committee, the RBI's committee on AI regulation, right? And this committee will decide the future of how AI is regulated in financial domains, right? The US, for example, is heading in one direction. It's saying that we don't need any regulation at all on AI, and AI can work the way it wants. The European Union has again a different course, right? Which is that it wants regulations and it wants um, a lot of different sort of regulations on AI, such as privacy and fairness and so on. And there are these contradictory approaches, and the future is very, very uncertain where we are heading to, right? And it's very, very important to be aware of these topics. So we have defined what we mean by human-centered AI. You could call it you could call it by other names, like you can call it responsible AI. You can call it societal, whatever. I like to call it human-centered AI because the human-centered approach is very, very important, because we want it to work best in the best interest of humans. And particularly, we want to train on human data, fine-tune with respect to humans and so on. Okay. So, how many of you know these stages of the machine learning pipeline? Are you aware of this at least? Okay. So the first stage is you can have many different variants of it, but the general idea is that you first define the objective function that you like to train on. You gather and pre-process data. Okay. So objective is defined by some of the metrics that you want. Maybe it could be business metrics. It could be like some of the other metrics that you would want. You gather and pre-process data. You choose appropriate models, like whether it's going to be like 10 layers, 20 layers, whatever, whether it's going to be deep learning at all or not, right? You train the model, you evaluate and refine, and then you test and then deploy the model. And then you can have multiple iterations where you have deployed the model, then you learn something is not good, and then you've again redefined or you tweaked your objective, and then again gather data. Okay. So today I will talk about how you need to be careful at each stage of this pipeline. Okay. So the first thing is defining objective function. Okay. So defining objective function is actually a very, very important stage, and you really need to be careful as to how you define the objective function. Okay. So has anyone watched this movie? Okay. So a lot of people perhaps have watched this movie. Can anyone explain the plot of this movie? Come on, speak up, someone. No, there is no. I'm not an AI. Come on, I'm not. Okay, you watched it. Yeah, yeah. So you kind of remember most of it, I guess. But so this Ultron is an AI which is created by Tony Stark, the famous Tony Stark, and the objective function is to protect Earth. Okay. So the objective that's given is protect Earth. That's the objective. Like if Earth is not protected, then you will have high loss. If it is protected, then you have low loss and so on. So you cannot specify that objective function. But the inference that it made is that humanity is actually a threat to Earth. Okay. So humans are the ones that are destroying the Earth. Then the natural solution that it figured out is, in order to save Earth, I should wipe out humanity. Right? I should destroy humans in order to protect. Okay. So what is the problem here? So the objective perhaps that you specified was ambiguous, or it had a chance of misinterpretation. Okay. You never said that like humans protect humans as well. You could have added a constraint protect humans, protect Earth, right? So if you specify an objective function, the AI will just look at the objective function and just operate according to that. It can come up with solutions which are like shortcut solutions. which are undesirable or are unintuitive to humans. But since AI is only looking at the objective function, intuition doesn't matter, right? It will just try to optimize the objective function and not chemical. There is another example which is from Indian history of this. So when the British came to India, they basically had a lot of problems with snakes, and they asked people to catch snakes. So for every sort of snake that was caught, or was basically you can basically hand a dead snake and get some money in return, right? So that was the objective function. And so people drew this inference that you catch so more snakes means more money. So what people did was they tried to breed snakes and have more snakes, and suddenly there were a lot more dead snakes in the city. Right after the reward was announced. So they thought that of specifying this objective function, that reward on dead snakes, would mean people will find a shortcut that they will start breeding snakes just for the sake of it. So the problem that we are sort of interested in here, which is in recommendation system. Okay, so this is something that is sort of something that you should pay attention to. All of you have used recommendation system in some form. If you have used Facebook, Netflix, whatever, right? Typically, the objective function that's given is to maximize user engagement. Ideally, we should maximize the utility of the user, right? Does that make sense? Is the difference between utility and engagement clear? Can you explain the difference between utility and engagement? Anyone? So, when you are trying to maximize utility, you are basically trying to maximize user satisfaction with the content. Like it could be like some informative content, it could be something which is sort of improving your utility, overall utility, right? You feel happy after it, and you sort of it adds value to your life, right? Engagement, on the other hand, is just how many ads you're clicking, how many times you're liking, how many times you're sharing the content, and so on. Utility is something which is very hard to capture, right? I don't know, your utility can be different from your utility. So it's also a personal thing. And we don't have means to capture utility, right? If only we could ask like a post survey that how happy were you with your with the current Instagram reels that I showed you. So if you can ask post hoc that like conduct surveys of this kind, then maybe you can get a better idea of utility. Otherwise, people don't tell you I'm getting this utility, right? How many of you have filled surveys on YouTube or Instagram? Also, there is. Does anyone fill surveys? Sorry. Yeah, social media, there are often surveys like, is this given by the just getting a random guy. So there are surveys that are encoded. Oftentimes on YouTube, if you see, you can see surveys. Is this, do you like this content or this content? Could be like some article. Yeah, or about the content itself. On Instagram, Reels also, if you see sometimes it asks you interested, I'm not interested, things like that, right? Most of the time, people don't fill those surveys. So the only measure that you have is to maximize user engagement. Okay, so you can only measure engagement. You can only maximize the engagement, right? So The inference then, since you don't know utility, you only know whether someone is liking or clicking and so on, right? The inference, the idea is to use engagement as a proxy for utility. So the idea is that the users like what they click. Okay? And this is a reasonable thing because of the principle of revealed preferences. Because you say you clicked on X in the past, that means that you like this content, then I can show you more of that content. Right? So click means like, and it also means show, like it could mean you can show your show more of that content, right? So the natural solution is that you show click worthy content. Does that make sense? So the extent of social media addiction, right, created by this, I can see like 50% of you are on phones or something, right? So that's how engaging things are. Like there's an interesting lecture going on, and I can see still so many people on phone, right? So this is something that we have to be very, very careful about. Like this is the opportunity to learn, and you think that that's the most important thing at this time, right? So what social media companies do is sort of use this utility, sorry, engagement as a proxy for utility, and it seems like a reasonable thing to do. You click on something in the past, you like something, and then you show more of it. But the question is this principle of revealed preference really valid or not, right? Because let's say you are at a party and I offer you some chips, and you may instinctively start eating all the chips, right? You finished the entire bowl of chips. What should I do next? What should I do? Ask, right? That's perhaps. What if you don't respond? So the natural thing to do is to give more chips, perhaps, because you think, okay, the person finished the bowl of chips, the person may really like chips, so I should provide more chips, right? That's the thing. So in this case, this principle of revealed preference is not valid because of the problem that humans behave impulsively a lot of times. So you're not sure whether that since the person finished the bowl of chips, was it impulsive or was it according to the person's true utility, right? Because we are not acting according to our true utility all the time. Sometimes we are just acting impulsively, just mindlessly scrolling on reels, right? And if the system just thinks that, okay, um, the person is scrolling on reels means that this person likes reels a lot or this type of reels, show more of it. That's not a valid sort of inference because you're not really acting impulsively at that moment of time. If I could know that you are acting impulsively, not according to your utility, then I would be able to correct that. The problem is that I don't know. Okay? So the thing is that humans exhibit this complex decision making, and people in behavioral psychology have specified that users have two types of cells. One is system one and one is system two. So there's this famous book called Thinking Fast and Slow. If you get a chance, please read that book. So it describes humans having two type of decision processes or two types of minds, so to say. System one is impulsive and fast acting. Okay. So it's like that sort of desire to just scroll, or it could also be first thing in the morning, I have to do this, right? It just, you're not thinking about it, it's just an impulsive action. Whereas system two is more like long-term decision making, it acts according to its true utilities, right? It exhibits long-term plan. And whenever you're making a decision, it could be a system two decision, it could be like a well thought out decision, or it could be a system one decision, like just scrolling or just just having an impulse for doing things. And oftentimes, what happens is that observed behavior is misleading. Okay, because the observed behavior it can be either due to system 1 or it could be either due to system 2. Okay. So the long-term user utility, which we define as system 2, it can be confounded by short-term tendencies of the user, and that could create a lot of problem in measurement because you're trying to measure how much this person likes the particular reel or not, how much this person likes the session or not. But a lot of the times, sometimes you are just impulsively scrolling or impulsively looking at cat videos, let's say, and then the next moment, like 3-4 days from now, it will only keep showing you cat videos. But you were just there was just a time when you just impulsively scrolled at cat videos, and doesn't mean that you really like them, right? So the thing is that we have to think very hard before defining objective functions, because of these shortcuts that the system that we can take. We think that utility is a good proxy for engagement, but it may not be, right? And this inference that users like what they click is not a correct inference to make, and we have to be very, very careful as to whether these session level engagement metrics are a good proxy for user utility. They could be for some use cases, but sometimes just based on like, click, share, you're not able to predict. And perhaps there is a hierarchy. But if the person is sharing something or directly messaging, maybe it's a better proxy for utility. Maybe it's better correlated with utility. If the person is not liking or if the person is just liking, a lot of those likes or scroll or watch time, these could be like very impulsive, right? So just to understand how correlated different metrics are with the user utility, and also trying to do surveys or thinking about long term, should be a good idea. Okay. So if you want to learn more, I've also done some research on this paper titled System 2 Recommenders. Uh, Definitely um, feel free to look at it. I also teach a course called Human Centered AI in this semester. So it's currently going on. You guys can take it next time to learn more about this. But for now, let's move on. So there are other stages of the pipeline. So first we look at the defining objective stage. How you have to be very, very careful about the objective function that you are defining, and what are the proxy solutions or shortcut solutions that might emerge from that. The other stage is gather and pre-process data. This is another very important stage that you have to be very, very careful about. So let's say you are developing an AI interviewer, and the goal is to maximize your predicted success rate of a candidate. Okay. So you look at the CV of the person, you look at the GPA, the interview score, and so on, and you make a predictor how successful this person will be in the future, right? Well, if I hire this person, how successful this person will be, like based on some performance reviews and so on. So how will you build a system? You look at your current employees and you look at the CVs at the stage when they were interviewed. So look at all the data like the interview score, the GPA and all that, and look at the performance reviews of your current employees, right? And see how well the performance reviews correlate with the CV at the time of interview, right? So you build a model that predicts from CV to the final performance review after 3 years or whatever. Some measure of success, right? So you train this model, but what if this particular data or these performance metric are biased against some people? Could be biased against some gender, it could be biased against something. Maybe the managers in your org, right, were repeatedly giving low performance review to one particular type of people and higher to another type of people. So there is this bias in your organization, right? You might have done everything right, in terms of your model, but it's just that your data was already biased, right? So that bias will actually seep into your model, because the model will, even though two CVs are very, very similar, you might give consistently lower success rate prediction to one particular type of people and higher success rate prediction to another type of people, right? So there is another problem about stereotypes, right? So let's say you are building some LLM, and a lot of the things are actually statistical knowledge. A lot of the things are actually knowledge that you should care about, like um, eating this after this food can cause some problems and so on. But it could also be like some stereotypes that are there in the data, like Asians are good at something, right? These types of stereotypes can also be there. Now, how do you filter from fact, which is like a true fact, from stereotype, right? So your AI model can have both the statistical knowledge learned from data, but it can also have stereotypes. How do you filter them? um, you could have lack of representation. So, for example, we talked about diversity. In the when I said imagine president was only showing presidents of the US. So, what if you have all the data that's trained, your LLM is trained on is 90% from America and English sources, right? You could then have a problem that the LLM has just the American centric, right? It never captured local languages and so on. And similar thing happens in, for example, vision models. So if you have like 80-90% white faces in your training data set, it's kind of natural that the loss function is only optimizing for accuracy on the majority class, on the 80-90% white faces or whatever, right? So it might naturally be bad at recognizing dark features, right? So if your model has, let's say, 95% accuracy, right, and 90% of your data is coming from the majority class, should you be happy about that model or not? Why? So 90% data is from majority class, and your model has 95% accuracy. So what can be the problem? Anyone? Right. So you could have 90% like complete accuracy in the majority class and just be random on the minority class, right? So that's what happens in practice. If you minimize the loss function for your data, and a lot of the data is only about this, the gradients will also work. Most the gradients will naturally be uh, taking higher weight for the majority class and low for the minority class, right? So these are some of the problems basically that happen with collection of data. And if your data has misrepresentation or underrepresentation and biases and so on, it could lead into your models and it can have problems with the approach. It could be that there is one view or one American centric view, let's say, that's overly represented and some other view is not. You could have also problems when you're choosing some model. For example, you could choose a model which is non-privacy preserving, and it could lead to like data leakage. There could be various attacks. That's another sort of type of issues in AI models, that if the model is trained on certain type of data, you could make inference about that data. Okay. So let's say it contains some sensitive information about you. There are various types of attacks that can reveal different types of information about you. Okay. So a very famous example is Netflix, where Netflix released its public data set. And what happened was that this data set had an entire viewing history on Netflix of different people. And there was some data set which was IMDb data set, which is a publicly available data set. And people figured out that the individuals in IMDb, you can find their identifiers and you could sort of do a matching, because Netflix data set is the full data set, contains entire viewing history. IMDb people post rarely. People could match the IMDb users to Netflix users. And in that way, they could reveal the entire history. of the entire viewing history of users, for example. There are many different types of attacks that are possible. Like you could reveal like social security numbers and so on. So you have to be very careful when you're designing model that it doesn't leak privacy and individuals' data. And there are laws according to that. When you are training the model, you could have a problem which is sort of non-robust. If you train in a non-robust manner, you could have a problem that a lot of these images can contain, uh, let's say, black swans, which are very rare. But since your model was not able to generalize, or you didn't train in a robust manner, you were not able to recognize those black swans. Or you train on stop signs, but then someone put graffiti on it, right? Humans are able to recognize that it's still a stop sign, but the model might not be able to because you are not robust. Okay. Lastly, in the next 1 minute, I guess, we can slightly talk about evaluation. So evaluation is perhaps the most tricky of all. Um, like you have feedback loops. So you take one decision according to the model, and it creates a feedback loop, and it kind of becomes a self-fulfilling prophecy. For example, in predictive policing, you figure out that one neighborhood has larger crime, but even though it wasn't a larger crime as compared to another neighborhood, but it's just some bias in the model, you do some algorithm on top of that, and you say that, okay, this neighborhood has larger crime. You send more police to that particular neighborhood. Since you send more police to that neighborhood, you discover more crime in that neighborhood. And then you are like, okay, you declare victory. Oh, we said so, right? But you're sending more police to one and less police to another, right? And then you get even more biased because you think, okay, this neighborhood really has larger crime. You even send more police to that neighborhood. Now you declare even more victory. Okay, we were actually right all along, right? But that initial bias in your prediction led to this sort of self-fulfilling prophecy. Similarly, what happens in recommendation systems? You predict which content of the will be liked by a person. You show that type of content, and since you're showing too much of that content, maybe you're making the person addicted, or maybe you're just getting unnecessary likes. It also becomes a self-fulfilling prophecy. Okay. So I will stop here, and if you guys have any questions, please feel free to ask. In the next lecture, we will look at the entire taxonomy of human-centered AI approaches and look at things in more detail. But this was meant to be more of an introduction.